All right, commencing the class properly right now. Good day, everyone, and welcome to today's training session. This is to officially welcome each and every one of you to this very session of our course on solar power system installations. By now, you guys are aware of what we do and how we do this thing. We commenced the class yesterday, or should I say a few days ago, and we have been able to walk you guys through the process of being familiarized with solar energy, solar system, and the various solar components used for solar system setup. In that course we had previously, we took our time to explain out what a solar system is and the various types of solar system. We told you guys categorically that there are two types of solar power system. One, the on-grid, and two, the off-grid type of solar system. The on-grid types of solar system tells you and keeps you informed that you are going to have um, energy supply in your facility all day, all time, 24 hours. That simply means that you have the opportunity or the flexibility of being on more than one power source of power supply source at a time. Then the off-grid type of solar power system tells you typically that you are only going to be on one type of power supply source, which is your solar system, which is your solar panel. And that simply means that if the solar panels are not generating energy for you, you might be in dark. And if your backup system is not also generating, is not also not generating, not also having enough energy storage in it, you are also going to be in the dark. So you see, the two of them have their own advantages and disadvantages. We told you categorically clear that there are four basic solar components used for solar system installations. We have taken our time to break down, to talk about these various four components. We talked about general maintenance and your types of uh, connections. So who are we here today? Mr. Kennedy, please, you would have to mute yourself, okay? There's a lot of noise coming from your end. So, why are we here today? What are we doing here today? We are simply here today to look at something very interesting. At the end of each of our training courses on the WhatsApp platform, we usually get this um, question: what component, what sizes of component, what size of inverter, what size of battery, what size of solar panel, what size of charge controllers would be suitable to run a solar system. And in attending to those kind of questions, we usually tell you guys that there are things you need to take care of first if you want to set up a very good solar system. What is that thing you need to take care of? It is called energy audit. What is energy audit? Energy audit is a calculation or series of calculations which helps you to know your energy need, which helps you to take care of your energy need. How much power will you be drawing from the system, that is the solar system, when it is installed? This your energy audit will then also help you to size the various solar components. So from here right now till the very end of this training course, we are going to be talking about energy audit, system design, load analysis, calculations that has to do with your solar system. You all are welcome. Once again, you are all welcome to VatViewTech virtual classes. It's going to be a very interesting ride. It's going to be a very interesting journey with you all. We will take our time bit by bit to explain out all these things. All right. we might be a little bit fast in these sessions due to the fact that one, it is free, two, we need to cover up to attend to other things. However, when we commence the paid classes, it is not going to be like that. We will take our time. For those of you who have already paid, you are really going to enjoy the classes because you will be having your time to ask a whole lot of questions, to learn a whole lot of new things before the training course will come to an end. Okay, so for your information too, this class is also being recorded as we are live right now. Yes, it is being recorded as we are live right now and is going to be shared with everyone who fulfills all righteousness. Now, the key thing there is who fulfills all righteousness. Yes, to be shared with everyone, but only those who fulfills all righteousness. Yes. So when you'll be complaining of having network connectivity issues, you are not able to connect, you are disconnecting, you are not getting the lectures clearly, please do not panic because the videos or the class is being recorded right now and the videos will be made available immediately the class is ended. All right. There will also be time for questions and answers on this very platform. Please, when it is time for questions and answers, what you need to do is very simple because we will attend to so many questions on this platform, okay? As many questions as possible that will come to us, we will try to take them. But then, please, you must speak from a quiet background. If you are not in a quiet background, what you need to do is to use the chat box. Yes, some persons have already started using the chat box here. Like, let me see, there's a message in the chat box already. So you use the chat box, send in your message, we will read it aloud. So if you can speak to us, no issues. All you need to do is to unmute yourself, tell us your name and your location. You are telling us your location for networking sake. Yes. So we want to know where you are from. We want to connect with you too, so that we will be able to not just coach you, but also be able to do business with you. All right. Now back to our course. I believe you all can see my screen. Please let me know if you can see my screen. Mr. Kennedy, can you see my screen clearly? Okay, Mr. Med can see my screen. I want somebody who can speak to me. Mr. Kennedy, can you speak? Mr. Duncan, can you speak to me? Mr. Jacob, I want somebody who can speak to me, who is in a quiet background, so that I will be able to know that you guys are there too. I only got a response from Mr. Med. Is he the only one in this class?
Yes, I can see a screen.
Okay, thank you. All right. So, just like I said earlier, all right, Mr. Willie can also see it. So what I said earlier was the introductory part of this very course, and we said that this is the very beginning of the premium class. All right, and we are going to be dealing with energy audit, as you can see on my screen. Energy audit is the determination of the energy requirement for a building. It is a careful examination of the electrical loads. It is crucial for standalone systems commonly seen in Africa. Now, what they are trying to tell you here, or what we are trying to let you know or inform you here, is that energy audit is divided into two. On one hand, it takes care of your energy need, and on the other hand, it helps you to size your various solar components. What do we mean by your energy need? We are simply trying to inform you or tell you that energy audit helps you to know the amount of energy in watt that is being drawn from your system. How much energy are your appliances going to be drawing from your system when it is powered up? In watt? Is it 1000 watt? Is it 2000 watt? Is it 3000 watt? 4000 watt? So what is the capacity of the quantity of appliances that you are going to be feeding to your inverter system? That is what we are talking about here right now. Now, this your energy audit, after it has helped you to know that your energy need for your facility, it will then use the information of your energy need for your facility to then size your various solar components. That is to say, if you must have known how much energy you are to draw from the system, let's say your facility is consuming 5000 watts, you are now going to be using 5000 watts to size your various solar um, components. Okay, you are going to be using 5000 watts to be sizing your various solar components. That is what it simply means. So in summary, if your size of load is 5000 watts, you can now say, okay, 5 kVA inverter can be okay, 10 solar panels of 600 watts is okay. For the backup of the batteries, you'll be talking about using like 8 batteries. 60 amp charge controllers would be fine. But then the basics of all this your system design is the energy need of that your facility. Moving ahead, energy audit helps you prevent oversizing of your system, safeguarding your electrical appliances from damaging from inappropriate power surge, and generally saves you costs. Now, let us talk about that a bit before we proceed. We have said energy audit helps you prevent oversizing of the system, and also it gives you safety to your system. Also, it helps you to save you cost. Let us connect item 1 to item 3 while we leave out the item 2, which is the safety. Item 1 there is oversizing of the system, preventing oversizing of the system. Item 3 there is generally saving you cost. Let us connect those two items together. How does it prevent oversizing and how does it generally save you cost? Let's take for instance, Mr. Willie, who is here with us for tonight's class. We don't know where Mr. Willie is from. Let's say Mr. Willie is our client for tonight. Our client for tonight's class. Let's say Mr. Willie has invited us to run a solar system for him in his facility. But on getting to that facility, we in fact, we didn't even bother to get to the facility. We just asked Mr. Willie what does he want. He said he wants to install a solar system. We didn't ask him any questions at all. We just brought in one system and installed for him. But on the long run, we discovered that what Mr. Willie needed to power up was just two bulbs and his handset. But then the system we brought for the installation is about 5 kVA, which means that that system has been overestimated, it has been oversized. Therefore, the basic consequence or the major consequence in that is that you are going to be incurring a higher cost, which means if you take your time to go through energy audit, sizing Mr. Willie's facility holistically by saying, okay, Mr. Willie has two bulbs, let's size the two bulbs, let's size the phone, what are their energy consumptions. We then know the exact size of inverter system suitable for Mr. Willie's uh, facility. In that instance, we have been able to save Mr. Willie some money because we got the exact amount of or exact size of solar system suitable for that facility. Now, when we talk about safety as it concerns the solar system, that is on another aspect, on another level entirely. If you all remember, during the end of the training session in the last class, somebody asked, is earthing important? Yes, we said yes. It's a very important question. It's a very good question. Earthing is very, very important, and earthing is a part of system safety. Just the same way you safeguard your conventional form of electricity, that is a grid, it is also very important for you to safeguard your solar system. As we proceed, we will be introducing safety to you. Okay, we will be introducing safety to you and safety tools and gadgets that you might be needing or you will be needing in order for you to um, have a proper solar system setup. So on my screen, the last paragraph you can see on this energy audit is telling you that in summary, energy audit uh, links the energy needs of a facility to the sizing of the various solar components required for the system setup. That is what I have been saying all this while. All the grammar, all the explanation I have been giving all this while, it all boils down to what this paragraph just tells you. Energy audit is that link between your um, energy need of a facility to the various sizes of your various solar components. Now, as we proceed, before you can carry out a solar energy audit on a facility, there are things to consider during solar energy audit. One, the list of electrical appliances to be powered by the solar system. Two, the power rating of the electrical appliances in watt. Three, the daily running hours of the appliances. And four, the total energy consumption of that your building. So these four parameters, these four items, or these four things are the things that you need to holistically look into in order for you to say you have carried out a very good energy audit on a facility. As we proceed, you are also going to be seeing how these parameters will play out. So please, for those of you who are writing, put this down and hold it tightly. Yes, hold it tightly in your hands because we will get to a stage in tonight's class where you get to see how these parameters play a vital role. The list of the electrical appliances, the power rating of the electrical appliances, the daily running hours of those appliances, and the total energy consumption are the things that will help you to really carry out an energy audit on a facility. Now, this is just a few notes on the importance of solar energy audit. Provides you the data needed for the appropriate system design, helps you identify opportunities to reduce energy use, helps you to reduce the capital cost, and help you to ascertain the backup time for the solar storage. So this is well explanatory, this is self-explanatory, this is well explained, and you also have some other advantages, importance, disadvantages of energy audit in our training manual. Okay, the PDF document we told you guys that we have that is available for you guys, we have it in there. If you have not gotten your copy, please, you know what to do to get your own copy, and please try to have it. There is a whole lot of information on this topic, energy audit, in that manual. So let's now discuss safety. Let's now discuss safety. I hope you guys are still here. Mr. Willie, can you hear me?
I can hear you well. Okay.
All right.
We are here. We are here.
Okay.
Okay.
All right. Thank you. Thank you so much. Thank you. So, now talking about safety proper, like we told you, remember that we said energy audit helps you take care of three things earlier. We said it helps you to prevent oversizing of the system, helps you save costs, and also helps you take care of safety. We connected how it helps you or prevent oversizing to generally saving you cost. Now we want to talk about safety. If you remember clearly, when we introduced the various solar components, we said there are four basic solar components. Anywhere in the world you want to set up solar system, there are only four basic solar components you need. One, the inverter system. Two, the solar panel. Three, the battery system. Four, your charge controller. These are the four basic solar components. However, we went ahead to tell you there are other components that are used or that can be used for system setup. What are these components? They are basically safety tools and gadgets, which means there are tools for safety of your solar system. What is safety? Safety in solar system is the act of keeping the entire solar system and your home appliances safe. Yes. So when you talk about safety, like I introduced it briefly earlier, you are trying to not just safeguard the life of your home appliances or house appliances or loads. You should also do well to safeguard the life of your um, solar component or solar system, right from your solar panel down to your inverter, down to your charge controller, down to your batteries. It must be safe. Something as little as dust can um, hinder your solar system from performing optimally. Therefore, you need to. Mr. Kenny, please mute yourself. I have been trying to mute you. What was happening with you? All right, thank you. So, Mace is having some network challenges. So, you must try to safeguard your solar system. Like I was saying, something as little as dust can cause issues in your solar system. Yes. Not to talk of your solar panels that is in the open space where you have a lot of dust, a lot of humidity, a whole lot of lightning, not even thunderstorm, lightning. So you need your solar safety tools and gadgets. Some of you, because due to the fact that you are professionals in electricity, professional technicians or craftsmen, you must have come across these safety tools and gadgets like your SPDs, your breakers, your changeovers, either a manual changeover or automatic changeover, and the rest of the components. You might be very well familiar with them, but then this is solar system we're talking about. Your solar system has two parts. Yes, I don't know if you know that, but your solar system has two parts. It has the AC part and it has the DC part. On no account should you uh, use your DC component for your AC side of your solar system. That simply means for your safety component as well, there are AC safety components and there are DC safety components. How can you be able to identify these things? How will you be able to size them accordingly? For safety, we have um, an advanced class which covers safety entirely. What we give you here, we don't give you in-depth knowledge of safety in this basic course, but for the advanced course on solar, that is where you get your in-depth knowledge on safety and everything that has to do with safety. So we also are advising you guys and encouraging you to also enroll for that particular advanced course after you must have finished with this basic uh, course. It is going to help you all. So a safe solar system is free from both human and natural disasters or hazards such as fire outbreak, overloading, overvoltage, undervoltage, lightning effect, and shock. What you can see me display on my screen right now are the various safety tools and gadgets. Like I said earlier, most of you must have come across it. On my screen, you can see your changeover, which is that changeover there is the automatic changeover. You can see your SPD, you can see your breakers, you can see your voltage monitors. There are two different types of breakers there. You have the MCB, you also have the MCCB. Do you know which part of your solar system you will be making use of for this your breakers, your MCB and your MCCBs? These are the things you are going to learn from this platform if you stay put with us. So this is your safety box where your or your PV box where you have all your safety tools in them. You can see the changeover there. You can see the breakers. You can see the breakers there. Your breakers are there as well. You can see your surge, your monitors. So this is the box that we're talking about where you do all the connections and the system will work effectively, perfectly. I hope we are still together. I hope we are together. Are you guys tired? Mr. Willie, are you tired?
Not really. I'm just enjoying.
Mr. Willie, I can't hear you. Are you speaking from are you connected your phone to an external speaker? You may have to disconnect it for us to hear you clearly.
Are you in class? Here in the class? Yes, I'm enjoying.
Okay, thank you so much. Thank you. Okay, so we may
Okay.
proceed. Now, what you have on my screen right now is electrical load analysis. What you have on my screen now is electrical load analysis. What is electrical load analysis? How do you come about electrical load analysis? What can you do with it? What business does it have in solar power system installations? Electrical load analysis is a series of calculations or processes of evaluating the energy needs of a facility. Remember when we introduced energy audit, we told you guys categorically clear that energy audit helps you to take care of two things. On one hand, it helps you to take care of your energy needs. On the other hand, it helps you to size your various solar components. Now, in taking care of your energy needs, there is a process, there is a procedure, there is a parameter which actually takes care of that your uh, energy need of the facility or calculating or designing for the energy need of your facility. What is that thing called? Electrical load analysis, or in short, load analysis. So load analysis is a series of calculations or processes of evaluating the energy need of that your facility. And like we have rightly said, energy need simply means or simply tells you the amount of energy that is going to be drawn from the system when it is powered, the amount of energy that your loads is consuming or are consuming from your system in watts. So in summary, electrical load analysis shows the exact energy consumption, that is wattage, of a specific facility. So, before you can carry out an electrical load analysis, there are basic questions you need to ask. Okay? There are basic questions you need to ask. One, the energy need of the facility. Two, the backup time of the facility. Three, what is the available budget for the facility? Now, let's take, for an instance, let's say our client for tonight, Mr. Willie, has invited us for a solar system setup in his facility, which is his house. And like we have said earlier, as professionals, we don't just recommend systems. We have to design, go through the process of energy audit by moving through the process of load analysis in order for us to size, firstly, to get the energy need and then the various solar components. So Mr. Willie has found us worthy to work on his facility and he has invited us. So on getting there, there are two standard questions to ask and a third one as a bonus. Those two standard questions are already on my screen right now, and those are the questions that you are expected to ask before you carry out load analysis. The very first question is to ask Mr. Willie the energy need of his facility, which is on my screen already. What is the energy need of the facility? So if Mr. Willie is a new person to this field, that is to say he has no knowledge whatsoever of solar system, he might now tell us that, oh, he doesn't know what energy need is. We can now break it down for him, and breaking it down for him, we will then ask him to give us the various list of the appliances he wishes to power up using the solar system. At this point in time, Mr. Willie can now tell us he wants to power up his inverter. He's not his inverter now. He wants to power up his television, his fan, his radio, his lighting point, which are the bulbs. So those are the things that Mr. Willie would be telling us he wants to power up using the solar system. We will say, okay, no problem. We'll scramble a little on our workbook or work materials, and then we'll come back to Mr. Willie and ask the second question: what is the expected backup time of the solar system? Now, before we go into the backup time, let's give you guys a basic understanding of what we are talking about. Now, remember that when we introduced the battery system, we categorically told you guys that one of the basic reasons why the battery system is included in the solar system setup is for the act of backup. If that is correct, you should also agree with us that um, the only source of power supply for your solar is through the sun. When one of the solar components absorbs the rays of the sun, convert it to electricity for you to be able to use in your facility. You should also agree that the sun does not stay up all day, which means there is a time for the sun to set, there's a time for the sun to rise, and there's a time for the sun to set. So when it is time for it to set, can you control it? No, which means you will be in the dark. Therefore, as engineers, we have come together to provide a workable solution, to provide a viable solution. What is this solution? To bring a battery, which we will be using to store up energy in form of battery banks, which also means that once the sun is up, once the sun has risen, we would harvest the energy from the sun through the solar panels at its highest point, store up some of this energy in our battery while we also use it in powering our facility. If that is understood, what is backup time? Backup time simply tells you that, or gives you the information of how long the energy stored in your battery system would last in the absence of any other power supply source. That simply means that when your solar panels no longer produce charges for you, you would be expected, or you'll be required to be on any other type of power supply, whether your generator or your grid. If those ones are not available, your battery is the next option. So how long will the energy stored in your battery system last for you in the absence of any other source of power supply? That is the backup time. It is in hours: 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. So that is what it simply means. So Mr. Willie will just tell us he wants the system to run for 12 hours. We will smile, smiling, not that um not that we are laughing at Mr. Willie. No, we are smiling because Mr. Willie is going to be in trouble. Yes, he's going to be in trouble in terms of the cost of acquiring that size of system, because the reality is this: the higher your backup time, the higher the size of system to be installed, and the more expensive it becomes to install that size of system. That is the reason why we would smile. So the last thing there is a very important question as well. Technicians and installers tend to shy away from it. Asking your client his budget will give you a clearer view and idea of how ready, how prepared the client is. Let's take, for instance, we have visited Mr. Willie in his facility and he has shown us what he wants to power up. It seems like Mr. Willie wants to power up the whole estate, but we have sized Mr. Willie using eye gauge. Ah, we have seen that Mr. Willie cannot afford this. So what do we do? Do we leave him? No. You still need to ask, sir, because appearance can be deceptive at times. So that is another reason why you should always ask, sir, how much do you have for this kind of project? In honesty, the client would give you that information. And when you have seen that the budget wouldn't be enough, what do? You then come down to advise the client on the next line of action to take. So, three key questions to ask before carrying out electrical load analysis. What is the energy need of the facility? You need to find out the backup time for the solar system and the budget of the client for the project. So, we'll also be looking at the importance of electrical load analysis. What are the importance of electrical load analysis? It ensures proper sizing of the system, prevent overloading, prevent fire hazards, improve safety and efficiency of the systems. Now, some of these things, some of this importance here might be properly explained, or you have get in-depth knowledge of it when we start designing the sizes of the solar component properly. So when we start sizing the solar component, you will get to see how this your load analysis plays a key role in this system design. All right. I know we have spoken a lot. I know our client is feeling what we are, the information we are giving out, and he's already filled up and he wants to pour out some questions, just like everyone on this very platform will also want to do. There is no issues. Like we said, there will be time for questions and answers on this very platform as well. So we'll give you that time to speak. For those of you who are going off and on, we see you. It is due to network connectivity issues. Like I said earlier, this class is being recorded as we are here right now. So, on request, it will be sent to you. However, you must have fulfilled all righteousness before it will be sent to you. Having said all that, let us have the first phase of questions for tonight. All right. From what we have learned so far, if you have any question or questions, let's hear from you, please. Please speak from a quiet background. If you're not in a quiet background, use the chat box. Or again, if you are in a quiet background and you want to speak, and you connected your phone to an external speaker, please disconnect it first so that we can hear you. If your phone is connected to an external speaker like your Bluetooth or headset, we might not be able to hear you clearly. So please disconnect and unmute yourself to talk to us. Is anyone talking to us?
Good day to everyone. This is Jonathan. Hope you can get me.
Yes, I can hear you. Your name and location. Then you can go ahead to talk
I
to
have a
us.
question on the back. Okay, I'm called Innocent from South Sudan, Africa.
Okay, go ahead, sir. Talk to us,
Yes, my
please.
question. Yes, yes, my question is on the backup time.
Okay.
Yo,
Yes.
iba bilang
So how do you determine or how do you calculate on the backup time that can be able to run the system when the battery is not connected to any external power charging, whether solar or electrical?
Okay. So your question is a very simple one. How you are asking how do you calculate the backup time when the battery is not connected to your an external power supply source. So like I said earlier, your backup time tells you how long the energy stored in your battery system will last. Okay, so that simply means that your client will tell you how long he wants the system to run. The duty or the importance of the backup time is to help you size your various size of or number of batteries. So that is the importance of the backup time. The backup time is a standard parameter which is used to size the battery system. So when we get to sizing the battery system, for those of you who will be proceeding, for those of you who have made your payment, so in the next class, when we start sizing the battery system, you are going to see how the backup time plays a vital role in sizing the battery system. Okay, because the backup time would be stated by the client, and then you use it to then size to know how many batteries or what size of batteries would be able to run for that length of time. I hope we are clear, sir. Mr. Angu.
Innocent. Yeah, thank you.
Okay, Mr. Innocent. All right, you're welcome, sir. Okay, thank you. So I okay. Okay, go ahead, Mr. Hassan Sinkala. Talk to us, please. I can see your hand up. Mr. Hassan, kindly unmute yourself if you can hear me. Mr. Hassan Sinkala, if you can hear me, kindly unmute yourself. Okay, maybe you're having difficulty, you can use the chat box. Okay, just touch the microphone on your on your screen so you can be able to speak to us. Okay, so we have a question from our client, Mr. Willie. Mr. Willie, you have not told us where you are from. Okay, so Mr. Willie is asking, what brings about load shedding even when you have done load analysis and proper sizing? Load shedding, do you do load shedding for your inverter system? I don't think you do load shedding for that. Or probably what you are talking about is load, what do you call it, load separation. Is that what you want to talk about? Okay, Mr. Willie, you are from Uganda. Load separation, because load shading probably is the that of your grid or so. I don't know if that's what you're talking about, but then for if it is load separation you're talking about, the one you do from your DB, it simply means that you are trying to remove those things that you have not included during the process of load analysis, so that your inverter system would not power them. That is the reason why you'll be doing load shading or load analysis. Because just as we have done in your facility, if we come to your facility, Mr. Willie, and we ask you what is your energy need, and you tell us you want to power up your fan, your radio, and your bulbs, that's your lighting point. But then we found out that in that same facility you are also using air conditioner, you are also using freezer, you are also using iron. What do we do? Do we say we want to install system for you? No, we will design a system that can power the items you want to power, which is your laptop, your radio, your fan. But then before the final commissioning, we will make sure we do a load separation in such a way that the inverter system or your solar system will not be able to power up what we have not designed for it to power up. So I don't know if that is the the side your question is tilted to. Okay, if not, kindly reconstruct so that we can attend to it. All right, Mr. Chancer, talk to us, please. I can see your hand up. Talk to us, please, quickly. Let's take one more question before we go. Mr. Chancer,
All right. Thank you very much.
yes, go ahead, please.
Yes, yes. I'm Chancellor from Zambian Dollar Copper
From where?
Belt. From Zambia,
Okay.
Dollar Copper Belt.
Okay, Zambia. All right, all right. Talk to us, please, sir.
Yes. Mm, yes, you've been talking about where the analysis of the facility. So, and you've said we can analyze if what type of the loads should be used at the same facility. So my question is there a package of to say maybe uh, uh, the what kVA can we supply to the facility which can accommodate the stove at what kVA can we recommend to the client so that we can do that, and if there is such that we can connect the package which can accommodate the load of uh, the stoves, those to say in short those with elements. You know, when I say elements, something which has which produce heat. Yeah, yeah. And another thing is I just want you to emphasize on uh, uh, on on those protective devices like maybe the amperage of the DCs and AC breakers at what sizes. Or I don't know if we're going to learn about it later or yes, but I just want you to assist me is there a package where we can connect so that we can even supply for stove,
Okay, so
ions, yeah,
okay,
etc.
okay, so I think you asked three questions. I'm only able to get two, and I'm only able to understand I think one correctly. The first one you asked about the inverter system. I don't know if you were asking how do you size the inverter system when you talked about package. I don't really get that clearly, but however, for you to size the inverter system that will be able to carry your facility, when you talk about your kVA, it is from this load analysis, it is from this energy need of the facility. Okay, so when we size the energy need of a facility now, you will get to see the size of the inverter, how to size the inverter system. What is the other question you asked, sir? Your questions are not too straight. Mr. Chancer, what is the other question you asked?
Uh, I'm sure it's just that one, just that one,
Okay.
and it's just that one. But I didn't hear the answer. You said yes, there is that package. The reason why I was saying it is the package here in Zambia, we buy things. They group them to say, okay, if you want to buy this package of inverter and the solar and the battery, they put them in. For example, if you are getting 3.5 kVA, is this much, and if you are getting 5 kVA, it is this much. That's why I was asking the
Okay.
package, so that I know if it is 10 kVA, so that you know, because in Zambia we have a bad road shading, so want to know uh, uh, people they want the package which can accommodate even the fridge. Yeah, that's why I use the package
Oh,
weight.
okay. So what that simply means is that you need to take yourself through the process of energy audit by firstly having a good idea of the energy need of the facility, and then you size those your solar components. Because before you can be able to say 3 kVA inverter system can power up two bulbs, one fan, one laptop, you must have taken your time to size it accordingly. That is what those guys in your shops are doing. Okay, so they must have been told this and that. All right, so I will take one more question from the chat box, then you can now write your other questions on your writing materials so that we can proceed. At the end of the class, we will take more questions before we go. So now our client again is asking Mr. Willie. Okay, no, I think Mr. Hassan is asking how can you connect earthing to solar system. So that is on the aspect of um, safety, and I explained it clearly that safety is covered, in-depth knowledge of safety is covered in our advanced class. However, if you have a project you are working on, Mr. Hassan, all you need to do is to pay your enrollment fee, and then we can walk you through. Yes, we will also walk you through the this editing you have issues with. So pay your enrollment fees, talk to us, we will then answer it. But if not, it is covered in our advanced course. That is the mini grid. You can even get the book and study it, and you are good to go. So um, we would like to proceed right now. I think I saw more hands up, but time is against us. Let us proceed, conclude, and then we can take more questions. There are more questions on the chat box, please. There are more questions. There are more questions here, and we are going to take it once we finish up with what we have right now. Okay. So now proceeding. I hope you all can still hear me. Our client, Mr. Willie, can you hear me? Can you see my screen clearly? All right. Mr. Is it Koros or so? Okay, sorry if I murder your name. Please pardon me. All right, thank you, sir. So now what you can see on my screen is a typical example of a load analysis table. Yes, it's a typical example of a load analysis table. Okay, let's say for instance we have asked our client Mr. Willie his energy need for the facility, and he has been able to provide us with he has been able to provide us with the uh, these various appliances. That is, he has told us he wants to power up his DVD player, his light bulb, his ceiling fan, his refrigerator, his blender, and these are the five appliances he wants to power up using the solar system. Now, looking at this thing is a typical example of a load analysis table, like we said earlier. Now, before you can be able to run a load analysis on a facility, you need to take into consideration three standard parameters. Yes, you need to take into consideration three standard parameters. One, the quantity of appliance. Two, the power consumed by the appliance. And three, the running time of that appliance, as you can see on this next screen here. Before you can be able to run a load analysis on any facility, you must be able to take into account three standard parameters. You must take into account three standard parameters. One, the quantity of appliance. Two, the power consumed by the appliance. And three, the running time of the appliance. Let's take them one after the other. The quantity of appliance. What is the quantity of appliance? The quantity of appliance simply tells you how many of the same appliance does our client intend to power up using the solar system. That is what it simply means. So on my screen you can see that the quantity of appliance is a standard parameter that clearly shows the number of the same appliance in a facility intended to be powered using the solar system. For example, if a facility has 4 units of freezers and 2 units out of the 4 freezers are to be powered up using the solar system, therefore 2 is said to be the quantity of appliance during load analysis stage. So let's say our client Mr. Willie has now called us to power up his facility. Getting there, there are 4 freezers, but then he wants to be on the solar, which means for the quantity of appliance for freezers, there are 2. I hope that is very clear. The power consumed by the appliance typically tells you or shows you the rated wattage of the appliance to be powered up. So the power consumed by the appliance shows you the typical um, wattage of the appliance to be powered up. So, and how do you get this wattage of the appliance to be powered up? It is gotten from the nameplate of that appliance. What is the nameplate? The nameplate is that place, that position or portion on the body of your appliance that contains the various details or the complete details of that your appliance. The nameplate will contain the name of the appliance, the serial number of the appliance, the IMEI number, the country of make, the shipping, the various details, voltage, current, wattage. So all you need to do is go to that your nameplate, lift your wattage from it, which is the power consumed, and then use it accordingly on your table of load analysis. On my screen, for those of you who can see my screen clearly, this is a typical example of a nameplate. So I don't know who can see the screen clearly. Who can tell me the energy consumed by this LG appliance? This is an LG appliance nameplate. Who can tell me the energy consumed by this LG appliance, or the power consumed by this LG appliance? Who can tell me that, please? Is there anyone here? Oh, Mr. Koros. Are you sure you are not using this kind of appliance in your facility, sir? All right, that is very correct. 195. Thank you so much, sir. Yes, 195 is the right answer. That is the energy consumption of this appliance. So you just take it and import it to your table of load analysis, and that is it for the day. All right. So, running time of the appliance tells you, or gives you the specific length of time the appliances will be turned on or in use. Please, it is worthy to note that the running time of an appliance only takes effect when the appliance is turned on. This is usually in hours. Okay, it only takes effect when your appliances are turned on, and it is usually in hours. It is also worthy to note that the higher the running time, the higher the cost of setting up that your solar system, and vice versa. I hope it is very clear. This one is very clear and very, very straightforward to understand. For further questions, you can also ask us. Now let us get into the deal of the day. We have asked our client, Mr. Willie, what is his energy need. He has told us now he wants to power up these 5 appliances: the DVD player, the light bulb, the ceiling fan, the refrigerator, the blender. Please, at this point, for those of you who really want to learn, you can write. Moreover, this is a bonus information. This is the only point you can write for free. Yes, this is the only time you can write for free. After this session, every other thing you are to do, you are expected to, you must have paid your enrollment fee. So please write everything you need to write right now if you don't have any intention to pay your enrollment fee. Okay, this one is entirely free and they are all valid information. So these 5 appliances, how are we going to power it up? We already have the standard parameters: the quantity of appliance, the power consumed, and the running time. Okay, yeah. So let us take the details of the 5 appliances. For the DVD player, the quantity, as you can see on my screen is 3. The power consumed is 100 watts. The running time is 1 hour. The lighting bulb light bulb, the quantity is 1, power consumed is 100 watts, running time is 2 hours. For the ceiling fan, quantity is 10, power consumed is 10 watts, running time is 24 hours. For the refrigerator, quantity is 3, power consumed is 10 watts, running time is 4 hours. For the blender, quantity is 1, power consumed is 80 watts, running time is 1 hour. So what is the energy need of this facility, or the energy consumption of this facility? There's a formula we will use. Okay, and that formula states that energy consumed per appliance is equal to quantity of appliance multiplied by the power consumed multiplied by the running time. How do you apply this formula? It simply means that you will use that formula to get the various energy consumptions of each and every of these appliances, sum it up, and then you have your total energy consumption, which gives you your energy need for the facility. And so, Mr. What is that? Where are you again? Okay, maybe you have left the. Okay, I think it's Chancer who was asking for the package. So this is the genesis of that package you are talking about. So when they get to know the number of appliances that's going to be powered up, it then use it to size your various solar components. So you need to pay attention to this. So for the DVD player, 3 multiplied by 100 by 1 gives you 300 watt hour. For the light bulb, 1 multiplied by 100 by 2 gives you 200 watt hour. For the ceiling fan, 10 multiplied by 10 by 24 gives you 2400 watt hour. For the refrigerator, 3 multiplied by 10 by 4 gives you 120 watt hour. For the blender, 1 multiplied by 80 by 1 gives you 80 watt hour. Altogether, we then have a total of 3100 watt hour, and that becomes the energy need of the facility, as you can see on this very table. So that is the energy need of the facility, 3100. Therefore, we are now going to be proceeding to the second phase of this course, of this training, in order for us to now know what size of inverter system would be suitable for Mr. Willie to power up 3100 watt of load, what size of battery can power this up, what size of charge controller would be able to charge those batteries, what size of solar panels would be able to also generate enough electricity to power up this kind of facility. I hope it is very, very clear. All right. Questions, please. Okay, so it is time for the second phase of questions to be taken. While you are getting ready, let us now, we promise those who have asked their question on the chat box that we will take it accordingly. Let's see. Is there a question on the chat box? Okay, is there a question? So okay, our client has asked previously, when does solar power system become dangerous to human and property? It's very simple: when it is not installed properly, when safety was not taken into consideration, you will have fire outbreak. When it is when overloading occurs, when you have your naked wires flying up here and there, you will be shocked, Mr. Willie. And if a lightning occurs, God save you. so so God save you, that you are not, that everything in your house is not shocking. Okay, so that is when it becomes when a bad job is done for you, that is when your solar system becomes dangerous to humans and property. So Mr. Koros, we don't know, he didn't tell us. Okay, he's speaking from Kenya, so he's asking um Mr. Koros is asking, how does inverter sizing and type selection, string, hybrid or off-grid impact system efficiency, battery life, and long-term reliability under real-world load variations and harsh environmental conditions? Oh wow, that's a very big grammar to use for this for this question. All right, sir. So you have to be patient. You have to also make sure you join the next um, training session, okay? Because this is actually a question on inverters. So when we get to that aspect, there are standard parameters that are used in order for us to achieve the sizing of your inverter system. Therefore, that is where we'll be able to talk about this your questions, okay? So make sure you are in that class. I hope you have paid the enrollment fee, because that is the only thing that will guarantee you to be in that class. And that class, let me give you guys an expo. Please don't tell anyone that I told you, okay? Because you're not expected to know that inverter class is happening tomorrow. Okay, please don't give out the information. I wasn't involved. Thank you. So go ahead, Mr. Innocent. Your hand has been dangling. Talk to us, please.
please. I want to ask about one two things. One, you may find a stubborn client. In the first place, when you go to do analysis, he gives you these items that is going to run. But in the long run, they may wish to add more of these appliances still on the same path. So how do we interconnect the two areas when they add more loads, more appliances, but when the load which I've already rated is less to what those powers can be generated for. And then the second one is about the earthing. I didn't understand very well about where do you particularly do the earthing on the solar system? Because what I know, earthing could have worked best when you're doing direct from a hydroelectric power. On the solar system, when it come on the regulator and the inverter, do we still need to do earthing, external earthing, or where do you do the earthing on a solar system?
Okay, so
Those are
Miss,
my questions. Thank you.
thank you, Mr. Innocent. So for the second question, we start with it. The 18 has been asked before, and we have taken care of it. I don't know if you are following up on all the information that is being passed on this platform tonight on the lecture. Okay, we say specifically for safety. Ask us in the next class. It is for paid students. All of you here, not all of you here have made your payment, so this is a general class for paid and unpaid, and anything on safety we don't take it in this open class. Okay, it is only for those who have paid. So Mr. Innocent, I don't know if you have paid. If you have, you have been added to a platform, so go to that platform and ask that your question. There's a paid platform you have been added to if you have made your payment. So ask that question there. If you have not, kindly pay your make your payment, so that when you come for tomorrow class you can ask us and we'll give you that details. It's a secret that only those who pays will get to know. That's what I have been trying to say all this while. Okay, we don't discuss safety openly like this. We can give you every other thing but not safety. Okay, it's strictly for those who have paid, who have enrolled for the course. Okay, so for your first question, which you asked, how do you determine when the client has overloaded the system, or when how do you monitor overloading as it occurs in the system? There are various measures to put in place. One is proper documentation. What is proper documentation? In the sense that um, you can prepare a document as a professional that gives details of the system you of the project you are handling, and at the end of the day during commissioning, the client would also append the signature together with you. It will bear the energy analysis and the sizes of system that has been installed. That way, when the system is overloaded and you are called back to check the system and you get there, you take a holistic look at the system and you find out it is an act of overloading. It is now at that point you can call to the attention of your client to tell him that, oh, this problem is his fault. He will be wondering how is it his fault. You will then say that, okay, look at what the system is expected to power up, but you have already overloaded it. Two, proper education of your client would also save you some stress. Okay, because some clients will feel like because they have spent a lot of money to set up a steady power supply in their facility, they can use it to run anything. No, it is not so. Okay, you need to tell them that there is a limit to which that your inverter system can carry. There's a limit to the load that your inverter system can power. Therefore, if it exceeds that limit, it is going to be a problem and it's going to be on them. It is very clear. Then there are smart inverter systems like the Lux Power, which you guys have in Zambia. Mr. Innocent, I believe you are a Zambian. So the Lux Power has functionality of global view. which makes it a smart system. If you connect if you connect the global view function to your mobile phone or to your computer, even before you get to the site, you must have found out what happened to that system, because the system will give you the total analysis, energy generated, energy transmitted, energy consumed, and the energy left in your battery bank. You will be seeing them live, so you might not have any issues. But the key thing there is to, one, educate your client properly, and two, you can have a proper documentation if you feel that your clients are difficult people to deal with. Properly document your project, let them append their signatures for future purposes. I hope it's clear, Mr. Innocent.
Yeah, sure.
Thank you so much. All right, so I think we can take one or two more questions before we proceed. Okay. Does anyone else have a question for us? Okay, I think there's a question on the chat box. Okay, Mr. Enoch is giving us some thumbs up to go ahead. Okay, so Mr. Enoch is asking, is the inverter part of the load when sizing the solar system? The inverter is not part of the load, okay, but then the inverter is a load on its own. Yes, the inverter is a load on its own, but not part of the load when you are sizing the solar system. There is a point where you will get to, which will cover that your inverter system as a load when sizing the load. Okay, so it's not at this point, but when we get there, you will definitely get to see it play out if you are available for that particular course. Mr. Enoch, I hope that is clear.
Yes, it's very clear.
Thank you so much. Thank you too. All right, so let us take one more question before we proceed. One more question before we proceed. Is there anyone who has a question? Our client, Mr. Willie, I hope we have been able to satisfy you, because you are going to pay us a whole lot of money for the good work we have done in your facility. Okay, Mr. Francis Alaba, is there any other disadvantage of solar power oversizing apart from finance? Um, uh, you also need to, once you oversize your solar system, you would also be it will not function efficiently. Yes, it won't function efficiently. So what is too big a solar system will also generate issues for you, because when you size your solar panels, yes, and the expected amount of voltages or current or wattage is going to produce for you, it's more than what your other component can accept. That is also a problem for you. All right. Okay, so in the absence of no other question, and our client Mr. Willie keeping quiet, I think we can proceed. I think we can proceed right now. So proceeding, this is now where we are going to be informing you guys it is the end of the session, and we are advising you to kindly enroll for the premium class to complete the training course. All right, so when we say it is the end of the session, we didn't say it is the end of the training, please. It's not the end of the training, but just the end of this particular session, which means that in the sessions to come, starting from tomorrow, we are now going to be designing to see, to actually size the various solar components, your inverters, your charge controllers, your batteries, your solar panels, and every other thing used for your system setup. Okay, so all right, Mr. Willie, thank you too for trusting in us. All right, thank you. So, it is at that point you will be getting to know or familiarize yourself with all these things. But at this point in time, it is here we'll put a full stop, and it's at this point you are expected to pay your enrollment fees if you have not paid by this time. A lot of persons have made their payments, and we're still expecting more persons to pay. Mr. Innocent, you are paying tomorrow morning. No problem at all, sir. We are here and available to receive your payment. Okay, so once you pay your enrollment fee, kindly send it into the platform for confirmation, and it will be confirmed, and you will get the training materials, videos, and PDF document, which will guide you in the course of this training. You are also entitled to attending live classes such as this one. Yes, you attend live classes such as this one. Very interesting classes. Yes, such as this one. You are also entitled to mentorship as it concerns your solar power system. So anything you face in the field, any challenge at all, you call us and we would help you, we will guide you. That your fee also covers the certification will be given to you at the end of this training course. I think some of you already know how much you have to pay and how you have to pay, but then for questions regarding that payment, please kindly let us know. For Zambians, you are paying 300 kwacha, Ugandans 45,000 Ugandan shillings, Nigerians 5,000 naira, uh, Zimbabweans 12 USD. If you are here, you have not heard your payment method or platform, please let us know. For Cameroonians, you have to pay um, 8,500 Cameroonian sefa. So let's go. General questions right now on the payment, please. On the payment. If you have any question on the payment, kindly let us know right now, please. Okay. For payment details, you can easily text me right now privately. You can text me privately on WhatsApp, and I will also send you the payment details so that you can go ahead to make your payment and get started. All right. In the absence of no other questions, this is where we shall be calling it a day on this on today's training session. Till we see you all again in the next training session. Have a wonderful night rest, everyone. Bye bye.